Bright Cutie. Every student matters.
Hi students, welcome to the session. In this session, we are going to talk about the properties of soil. One particular property that we are going to discuss is percolation rate of water in the soil. Before we understand this completely, we are going to let's understand what exactly do we mean by percolation. So it is the property of the soil to absorb the water, right? So how much water and how quickly does the water is absorbed by the soil is one of the properties of the soil. Whenever we are discussing the properties of soil, it is always different kinds of things that are there, whether how much what is the rate of percolation, what is the moisture content. All of these are the different properties of the soil and they vary from one soil type to another. In the previous session, we've already talked about the different characters of the soil. In this session, we are going to understand it a little better and we are going to see that how we can actually measure and how we can check this property. Now, what exactly do we mean by percolation rate? So, percolation rate is the amount of water absorbed by any soil at any given time. So, it is how much, suppose in 20 minutes, how much water do the sandy soil, how much water percolates the sandy soil, how much water percolates the clayey soil and how much water percolates the loamy soil. So, this is what we call as the percolation rate. And this is what we are going to measure. To understand percolation and what exactly do we mean by this property, we can do a simple activity. You can mark two different squares of 50 centimeter into 50 centimeter each. What you are going to do is you are going to take two areas. One is your floor, that is a floor in the house, right? It can be a veranda floor which has a tile or cement on it. And other is your kacha road, right? Kacha road is basically the road which doesn't have concrete in it. It has mainly soil. It is made up of mainly soil. Now what you're going to do is you're going to pour the water, right? Now you can pour say 200 or 500 ml water on this floor and same 500 ml water you can pour on this floor or this road. What you will observe is that on the floor when you are pouring the water, it does not get absorbed and the water will run off, right? Wherever there is a drain, it will go there, right? So even if you see at your homes also, suppose if by mistake your water falls on the floor of the kitchen, it has to be wiped, it doesn't get absorbed. Whereas if you take a kacha road where there is a soil, the road which is not made of concrete, if you put water over there, you will observe that the water is getting absorbed into the soil, right, into that kacha road. This shows that the water can be, the soil has the ability to absorb the water. And there is again variation in different areas. Even the floor, if you can see, even if it was made up of cement, not of marble or tile, then also you will see that the water will flow. It will be long time. It will take a lot of time for the water to get absorbed in the cement, and it might not get absorbed. Also, it might have, it might get evaporated due to heat. Right. So in this way, we see that absorption is present. This property is present in the soil. Now, what we are going to do is we are going to answer this question that Bujo is asking, that why is there a difference in the absorption of water in the two squares? The answer to this question is that the two squares, first of all, the square which we took on the floor was made up of, maybe your home has marbles or tiles on them, even the cemented floor. The percolation was not good because the spaces between all of these, there are no pores in between these tiles, in the particles of the tiles or marbles or anything. But when we talk about the kacha road that is made up of soil, it has, pores in it, right? So it has soil particles which have spaces in it, which allows the water to move it, right? To understand it in a better way and to see that what are the different percolation rates in different types of soil, we are going to perform a very interesting activity and you will really enjoy the activity by doing it. right? So what is the activity? In this activity, you will need some of the things. First of all, you will need a measuring cylinder or a 200 ml bottle in which you will measure 200 ml water. Now you can group your teams. First of all, take team A, B and C. You can take all the three types of soil. You can take clayey soil, sandy soil and loamy soil. Group yourself into these three teams. Then what else you are going to need? First, you are going to need this. Second, you are going to need a pipe, right? Now this pipe can be your tin can, right? It should be a little long pipe which you are able to observe, right? So you can take a small tin can or you can take a PVC pipe, right? You can take PVC pipe which has a diameter of approximately 5 centimeter and you can take it like 20 centimeter long, right? So you can use that also. Then what you are going to do, you are going to take an area. Let's say you have taken a box. So you can take an area where you are going to collect the soil, and over there you are going to, suppose this is the area where you have collected the soil and this is the area where you have collected the soil. In this soil, what you are going to do is you are going to place the pipe at least 2 centimeter deep. Why we are putting it 2 centimeter deep? Suppose this is the soil area, right? So you have to put the pipe so that it is 2 centimeter deep in it. Why we need to put it 2 centimeter deep? Because we do not want the water to to leak out, right? So if suppose the water was on the surface, right, then if suppose this is the surface of the soil and in this way you have kept the water, the pipe, what will happen when you pour the water, it will come out from the sides and it will hamper or it will give you a false result. So that's why we put the pipe 2 centimeter deep so that the water percolation rate can be calculated properly. We are going to utilize 200 ml of water, right? Now, what we are going to do is, we are going to take 200 ml of water and we are going to pour it, like you can see over here, we are going to pour it into the cylinder in such a way that the water should not go out of the cylinder and it should always be inside, within, from the pipe only it should go inside, right? Now what you are going to do is, you are going to observe, right? For how much time, what you are going to do, observe the time, right, in which the pipe is empty. That means the whole water, whatever water was there has percolated, is absorbed has been percolated and all the water has been absorbed by the soil. Once the water is percolated, the whole, the complete water is percolated, then you can calculate the rate of percolation, called as the percolation rate, with the help of this formula. Suppose the amount of water that we have taken in this activity is how much? It is 200 ml, right? And what is the percolation time? Let's say the percolation time was 20 minutes for sample A. Right, let's say for sample A, this is the percolation time. Then when we calculate it, we will find that the percolation time is percolation rate is 10 ml per minute, right? So in this way we see the percolation rate for sample A is 10 ml per minute. Maybe the percolation of sample B would be something else and the percolation rate of sample C would be again something else. So in this way we will be able to calculate the percolation rate of all our three samples and we are going to put them in ascending order as to which was the lowest percolation rate and which has the highest percolation rate, right? So in this way we will also be able to characterize our soil on the basis of the percolation rate as well, right? We can say whether loamy soil has more rate or the sandy soil or your clay soil has more percolation rate, right? Compare your data and in this way you are going to conduct the activity. It's quite an interesting activity and will help you understand the property quite properly, right? So always remember the formula, and now basing on this particular property we are going to answer some of the questions. Moisture in the soil. We are going to determine that whether or not there is moisture present in the soil. Now, all of you must have gone through, a farmland where during a hot summer day. If not a farmland, you must have seen a big farm or a big say garden, and especially during a hot summer day, what you will find is you will find a shimmering effect right above the ground. So, right above the ground, you will find a shimmering effect. Now, what is the reason? Have you ever wondered that what might be the reason of this shimmering effect that you are able to see? We are going to determine the reason for this shimmering effect, and for this we are going to perform an activity.
Take a test tube and put about 2 spoonfuls of soil sample in it. Heat it on a flame. After some time, you observe water droplets on the inner walls of the upper part of test tube.
Similar phenomena is seen in the case of your hot summer day. This is say a farmland where it is really hot, the temperature has gone really high, so the water vapor starts forming. That means the moisture in the water starts evaporating in the form of water vapors. Then what happens that the sun, which is the sunlight which is coming onto the land, onto the farmland, gets refracted, and what is happening? It forms the shimmering effect, right? So this sunlight gets reflected. The sunlight gets reflected, and this phenomena looks as if there is a shimmer above the land, right? So the shimmering effect that we saw was because of the heat of the sun and the water vapor that were coming out of the land because of this extreme heat. This experiment shows the presence of your moisture in the soil. What you can do to understand that how the moisture affects the texture of the soil, you can take the same soil sample. Say you take 5 tablespoonful of your soil, in which 2 tablespoons you have put in the boiling tube, but other 3 you will keep as it is, which are not devoid of moisture. Now when you will compare, you will find that the soil which we have boiled or which we have heated has become really dry, and the texture is not good. Whereas when you compare it with the texture of the soil which has moisture in it, then you will find the difference between the two. And also on the same spot you will be able to determine that how much difference of weight also is there, right? The soil which is dry will be lighter as compared to the soil which has more moisture in it, right? So in this way we see that how the moisture of the soil, the moisture is present in the soil, and how does it affect the characteristics of the soil, right? Now, absorption of water by the soil. So the first question that we are going to address is that do all the soils absorb the water up to the same extent? Now understand, when we are talking about absorption of water by the soil and when we think about percolation of water, there is a little difference. What is that difference? That percolation is that, suppose this is the block of say soil, right? So percolation means how much water is able to absorb and go beyond this, how much water is able to, the soil is able to absorb and it goes beyond it. That means it is able to move deep into the soil parts. Whereas when we are talking absorption of the soil, we are only concerned with this particular layer. How we are going to see that how much how much water can the soil absorb. For that we are going to do an activity, and with the help of this activity you will be able to understand the difference between the percolation and the absorption of water by the soil.
to find out the amount of water retained by the different types of soils like sandy, clayey and loamy. Materials required: iron stand, beaker, sand, clay, loamy soil, glass funnel, filter paper, water. Method: first assemble the apparatus with iron stands. Place one filter paper in each funnel touching its sides. Now put 15 grams of the sand, clay and loam in the 3 funnels, labeling properly and noting which funnel contains which soil. Place a beaker below each funnel. Now pour 50 ml of water slowly in each funnel. Leave the apparatus for some time till active dropping of water from the funnel stops. Now note the volume collected in the beakers below. You notice that sandy soil retains least water. Similarly, loamy soil stores less than sandy soil and clayey soil retains the most.
Completed this experiment, what we are going to do next is we are going to calculate that how much is the absorption or how much absorption was done by a particular soil. For this we are going to utilize a formula with the help of which we are going to determine the percentage of water absorbed and also the actual quantity of the water that is absorbed. Let's say that we have taken the weight of the soil as 50 grams. Weight of soil that we took was 50 grams. Now, the very first thing is to note down the initial volume of water. Initial volume of water means before adding the water to the soil. Let's say it was UML, right? Then what you are going to do is final volume of water. That is after you have added the water into the soil and whatever is left in the measuring cylinder is the final volume of water. So it becomes VML. Now over here what we are trying to find out is the volume of water absorbed by the soil. What will it be? It's quite simple. We are going to subtract the final volume with the initial volume, and this will give us the total volume of water that was absorbed by the soil. Also similarly we can also find out the weight of the soil that is absorbed by the water. So weight before pouring, that is the initial weight, which we are considering as U gram. Again final weight, which we are considering as V gram, and then again weight absorbed, is U minus V gram, right? Now here please understand and do not get confused that 1 ml is equal to 1 gram. So you shouldn't get confused with the same. So in this way we are going to find out the volume as well as the weight of the soil absorbed. Now what we have to find next is the rate of or the percentage of water absorbed. For this what we are going to do, we are going to use the formula U minus V upon 50 into 100, and this will give us the percentage of the water that has been absorbed, right? Now once we have conducted this activity, remember to conduct this activity with all the 3 samples If you want, you can do it on your own, or you can make the groups of A, B and C, and in that group A group can do the experiment with the sandy soil, B group can do the experiment with the clay soil, and C group can do it with the loamy soil. And then you can compare the result and you can discuss your observations. Once you have completed this activity, then we are going to discuss the questions. We are going to discuss these questions. First of all, which soil would have the highest percolation rate? So this we have already seen that the sandy soil has the highest percolation rate, and this is something which you will observe in this activity also, right? And you can definitely answer these questions after you have done the activity, but usually when we are talking about the properties, this would be the right answer. Which soil would have the lowest percolation rate? This also we have seen that the clay soil has the lowest percolation rate. Now, another question is, Bujo heard from his neighbor that 8 to 10 days after the rain, the level of water in a pond or well rises. Which type of soil will allow water to reach a well faster and greater amount? So, any soil in which the percolation rate is low, that soil will allow the water to reach the greater amount in quite quickly, and that kind of soil is the clay soil, right? So clay soil will allow quicker filling of the water or rise in the water level in the well or in the pond. Which type of soil retains the highest amount of water and which retains the least? So the retention is the least in again the sandy soil, and again the retention is the sandy soil has the least amount of retention, whereas the maximum amount of retention is in the clay soil, right? So the next question is, can you suggest any method to let more rainwater percolate and reach the water underground? So when we want more and more water to reach underground, what we are going to do is we are going to use a method called as rainwater harvesting, right? Or watershed management, right? In this, what happens is that we have, let's say this is a pond or area which we have dug, and we want this area, remember student, over here it is all soil, right? The water when falls in this pit, it allows the percolation of your water. From time to time we want to keep on digging this well or this pit, because we want the soil to be aerated so that more and more percolation can take place, right? So with the help of rainwater harvesting, we can increase the amount of water that goes underground, right? This kind of system is being used widely so that more and more water conservation can be done. The level of groundwater can be increased. Now, another question. Rajasthan is a desert state in India. Once while traveling to Rajasthan by train, Bujo observed several streams and rivulets of rainwater during the journey. But to his surprise, he did not see streams of water in the desert region even during the rains. Help Bujo find suitable explanation for this. So, a suitable explanation for this is that Rajasthan, being a desert, has sandy soil. And we know that sandy soil has the maximum percolation rate, right? And because of this reason, what happens is when the rain falls on this sandy soil, percolation of water takes place quite quickly and the water reaches the underground, and that's the reason why you do not observe river and rivulets in the desert, right? So sandy soil is the reason behind this particular phenomenon. So I hope you were able to understand all the properties of the soil, and that is your percolation rate, absorption of water and moisture in the soil, and how do these properties help in characterizing the soil, right? So I hope whenever asked you will be able to solve any kind of questions regarding the same.